Hello friends, welcome to my channel. Let's have a look at problem 2337 together. Move pieces to obtain a string. So the goal for this problem is that we try to recover a string target from the string start by obeying the moving rules specified in the 2 bullet points in the problem statement. So here in this video, we're going to share a method by simultaneously scan the start and the target strings and compare the characters and their relative positions. So we shall decompose the ideas into several points. The main points are as follows. First, let's look at these 2 strings. The second one is the target string. So this is due to more right scores in the start, right? So we can move the letter R to the right one time to recover the target. The second point is here. Look at these 2 strings. So the second one is the target string. So this is due to more left scores in the start. So we can move the character L to the left twice to recover the target string. So the third point is that the characters need count the same in the 2 strings, start and target, and they should remain their relative order. For example, this one is from example 1 in the statement. So we have L, R, R, and we have L, R, R. So the counts are 3, and these letters also maintain their relative position. So in this case, we return true. And a counter example is the following. So we can cook up from the example 1. So we reverse the L and R orders. So in the start, we have R, L, R. And in the target, we have L, R, R. So the counts are 3, but the order, relative order, actually is not okay. So we return false in this situation. So if we combine all the 3 points, so we actually can make the following procedure. So first, this is basically a loop. So we scan the start and target string to locate non-underscore characters, say at indices I in the start and J in the target. Then we want to consider different scenarios. First, if the start I and the start target J does not equal, then we should return false due to item 3. Otherwise, if they were the same, and then we consider the cases of different letters. If they were both character L, so we should be able to move the L in the start to the left or remain its current position. So we should have I greater or equal than J. In other words, if I is less than J, we should return false. And in the other case, if both characters were R, the character R, then we should be able to move the character R to the right or remain in the start string. So we should have I less or equal than J. In other words, in this situation, if I is larger than J, we should return false. So after the above loop, if we can recover the start, we can recover the target from the start, then both I and J should end at the length n of the 2 strings, due to the assumption that they have the same length. So this is the main procedure. So actually, the procedure can be understood using the following reasoning. So imagine if there were no underscores in both the start and the target. If we can make them the same. So this should essentially the same strings. Therefore, the corresponding same characters in start and target shall have the same index, that is, I equals J for each character. Then if we can recover the target from start, so it's due to added, so notice the quotation mark. So due to added add scores to the right of the character R in the start, or to the left of the character L in start. So that actually explains the relative position relation. So if the character is R, so we should have I less or equal than G. And if the character is L, we should have, so here we should have I greater equal than G. So if this is the case, we can achieve target based on moving rules in the problem. Otherwise, we cannot. So with that, with the above analysis and the specific procedures, we just need to translate the above procedures into a code. So let's look at the code. First, let's check the information for the length. So length, we can use target for this. We can use start for this. Then we can initialize some variable, say ij equals 0, to start the scan simultaneously for the two strings start and target. So while I less than n or j less than n. Then first we want to locate the non-add score characters in start and target. Let's do it. It's another while loop. So while I less than n and start I equals the add score. Then we're going to push I to the right. So I plus equals 1. So if we exit the while loop, either I equals n or the I corresponding to a character which is not add score. In other words, it's either R or L. Similarly, we do this for the target. So, but for target, we use J to track this. If target J equals add score, then we're going to push J to the right. Then we're going to first treat a special case. If I equals n or J equals n, we're going to break the while loop. And then we consider the cases that we shall return false based on the above procedure here, so item 2. If start I does not equals target J, this is the one case. Or if start I equals character L, and in this case we should have I greater or equal than J. So if I less than J, we're going to return false. Or if start I equals R. So in this case we should have because we want to move R to the right, we should have I less or equal than J. So if I is greater than J, we're going to return false. So once this case is done, we are going to increment I and J, right? I, J equals I plus 1, J plus 1. So to compare next character, right? So this is the while loop. If after the while loop nothing is returned, so we are going to check if this is the case, I equals n and J equals n. If this condition is true, it means we can recover start. We can recover target from start, otherwise not. So that's the full code after translating the procedure. So let's look at a special case. Yeah, it passes the special case. Now let's look at the generic case. It passes the generic case. So I guess that's about it for this problem. I guess the main point is to realize the relative order and the same count in this problem based on the moving rules. That's about it. Thank you very much.